Hi, good afternoon. Hi, welcome back. You guys are so sleepy from the break, huh? And you're like, and this is the last class of the day, and we're done. Do me a favor, just do your best. Join with me as let's get through this, and then we can all put our heads down, and we can nap. Okay. So today we're talking about rectangles. Rectangles, we're going to be able to identify and recognize the properties of those rectangles, and we're going to be determining whether or not the shape that we have in front of us is even a rectangle, because we're going to throw a rectangle party, and we're not going to allow anyone in who's not a rectangle. So we have to be able to check their ID. A rectangle, by definition, is some sort of four-sided shape, a quadrilateral, that has four right angles, and all the properties of the parallelograms that we were studying before the break. So as a reminder, our parallelograms had opposite sides parallel, had opposite angles congruent, and opposite sides congruent. The diagonals also cut each other in half. Okay? So rectangles have all of those properties and these two others. All of the right angles are right angles. And not only do the diagonals bisect each other, but they're all the same size. They're congruent. Okay? Let's jump right into these examples. I know I have a figure off to the right, but it's kind of small, so I'm going to redraw it here just so that it's with all my writing. Okay? So I have some quadrilateral, so four-sided shape, A, B, C, D, and I'm told it's a rectangle. Okay? So all the properties we just discussed, this shape has. Now I'm told that BE, I don't have a point E. Do you notice no point E? Well, if I draw the diagonals, I could name this point where the diagonals run into each other, I could name that point E. And so now I have a line segment BE. All right, so this line segment BE, I was given a measure of 6y plus 2. There's BE. And then I was told that I have another line segment, this one right here, CE, and its measurement is 4y plus 6. And we want to find the value of y. All right, so let's look at this. We know this is a rectangle. Rectangles, those diagonals are congruent. They're the same measure. So this line from B to D is the same length as this line from A to C. And they bisect each other. They cut each other in half. Okay? So this one has been cut in half. That means this piece is the same as this piece. And this one has been cut in half, so this piece is the same as this piece. But this diagonal is the same measure as this diagonal. And so if it was cut in half also, then all of those halves are all the same size. Okay? Think back to when I explained what bisect was. I had my birthday cake, right? Had one birthday cake and I cut it perfectly in half. Right? Each half was the same size? Yeah? Well, now imagine that my daughter went ham, and instead of baking me one cake, she baked one, she took it out of the tin, she washed the tin, and then she put more batter in and she baked a second one using the exact same tin. So now I have two birthday cakes that are both the same size as each other, and I've cut both of them perfectly in half. All of those slices are all still going to be the same size, because I started with the same size cakes, and I cut them in the same spot. Make sense? So that means that these two pieces are also congruent to the other two pieces. And now I can write an equation. I can write an equation that says that this segment has the exact same measure as this segment. And now I can do algebra to this and find out the value of y. Ready? It's a race. Who can find the value of y first? Y'all or me? Ready? Set. No pressure. Go. Thank you. I'll pause. We got interrupted. I don't want him to lose his time. Hi, thank you. You can go ahead and sit it there. Oh, okay, they fixed it?
Yeah.
Okay, so you're here for your bag? Okay, we'll see you after school. Thank you.
Kind of wanted that free period.
Everyone does. See you later.
Bye.
Bye. Did you get the same thing I did? Oh, that means I did it right. Good. Did I answer the question?
Yes.
Yes, because the question was find y. Did I find y?
Yes.
Answer the question, I'm done. Not bad, huh? All right. Number 2 is going to be the same sort of thing. And number 4 is going to be the same sort of thing. So I want to skip over and I want to do number 3 with you. Okay? I have the same quadrilateral with the diagonal showing. So there's A, B, C, D. And then I have the intersection where those diagonals intersect. I have that showing as E. All right, the next thing that I have, it says if. Now this right here reads measure of angle AED. So the M stands for the measure, that funny looking L that's like bending over, angle. So measure of angle AED. So AED right here. So that angle measures 12. Can you read that or is that too, oh, that's way too light. I'm so sorry. Let me change the color, make it darker. There you go. Okay, so that is 12x. And then this is measure angle BEC. BEC. This angle measure is 10x plus 20. And I'm being asked to find a measure. This measure, this angle. The definition of rectangle doesn't tell us anything on what to do with these angles, right? It doesn't have anything for us. But doesn't this look a little bit familiar when you color in angles that way? One more time? Okay. Do these look a little bit familiar? When angles are set up like this, they are, what do you think? Take a guess, even if you think you're wrong.
Vertical.
They are vertical angles. And vertical angles are always congruent, which means I can write an equation where this measure is equal to this measure. I can then solve for x. Have I answered the question? I heard someone whisper at me, no, like it was a secret. You're right. No, I haven't answered the question because the question isn't find the value of x. The question is find the measure of angle AED. And we were told at the very beginning that the measure of angle AED was 12 times the value of x. So 12 times 10, or 120. And that is my final answer. Make sense? Okay. At this time, I need you to turn the notes over to the back. And then have a moment of, what? Ain't nothing there, woman. It's because the copier totally forgot to put the second part of the notes on the back page for you. So we're only going to do part of these notes. We'll do them here. You'll handwrite everything. There isn't too much to draw. It's just a lot of calculation, okay? Okay. All right, so the first thing to write is quadrilateral ABCD has vertices. There's some music going on kind of on this side of the room. If that's you, do me a favor, just turn it down. It's still going. It's a little high-pitched. There you go. It's gone. Thank you very much. All right, so it has vertices. A, located at -3, 0. B, located at -2, 3. Can you see it? Yeah, okay. C, located at 4, 1. And D, located at 3, -2. And we've been tasked with this. Determine if quadrilateral, I can't spell, sorry, ABCD is a rectangle. Because we are throwing a rectangle party. And we're carding at the door. We don't want any triangles in our party. You know? We don't want any parallelograms. Well, we do if the parallelogram's a rectangle, right? If it's not a rectangle, we don't want them in the party. Sorry.
This D says 3 and negative what?
-2. This is a -2. Sorry about that. Okay? So we're bouncers, and we're going to check this guy's ID at the door. Hopefully he's not coming in with a fake ID. And we're going to check to see if it has the things that we need to see from it in order to say, yes, you're a rectangle, come in and have some punch. Okay? So the first thing I'm going to do is I'm going to draw this thing. Okay? Draw it. Bless you. I don't need to draw it very precisely. Bless you. Or very accurately. I'm just going to give it a quick sketch. All I'm really interested in is knowing what sides are opposite what other sides. Okay? So here it is. Here's my X and my Y. And I'm going to draw, okay, so -3 somewhere over here and 0 somewhere on the line. So there's A. B is at -2, +3. That means it's over here somewhere, but not as far as A is. And then up some. There's B. Jonah, later. C is at 4, 1, so it's going to be somewhere over here and only up a little bit. And then D is at 3 somewhere here, but not as far as C is. And then down into the negative somewhere. Okay, so there is my sketch of a rectangle. Doesn't look very rectangle-y, and that's okay. And yours might look more or less rectangle-y than mine, and that's okay. Yours is just as beautiful. Okay? But do label your points so that you know which point is where. Okay? This allows us a really good view of which sides are opposite which other sides. Okay? Because with this information, we can start looking at the characteristics of a rectangle. Our first method is we're going to use the slope formula. Okay? We're going to use slope because what we're after is we want opposite sides parallel. And consecutive sides perpendicular. Okay? So if we can get both of those conditions met, this thing's a rectangle, he can come into the party, and he can hit on all the hot parallelograms. We need our slope formula. Y'all remember the slope formula? Nope, you're like, the Christmas presents ate my brain, miss. Nope, I don't remember it. I heard y equals mx plus b, that is the slope-intercept form of a line. That's supposed to be an x. Slope formula is take the y's and subtract them, take the x's and subtract them. Divide. Okay? All right, so what we're going to do is I'm going to calculate the slope for each and every single line in my shape. So there's the slope for AB. Here's me looking for the slope of CD. Then I'm going to look for the slope of AD. And we're going to look for the slope for BC. Okay? Going to be using the same formula, bless you, and the coordinates that I've been given. Hi, you're writing all this? Okay. And then I'm going to compare them, and I want the opposite sides to be parallel. So I'm going to look at those two and just check that I have the same numbers at the end. Okay? So here I go. I need the y coordinates for A and the y coordinate for B, the x coordinate for A, the x coordinate for B. I have a double negative, so I'm going to get rid of that. And there's my first slope. Okay. I'm going to repeat for all of the others. I know there's like a lot to keep track of, huh? Okay, we're comparing these two again. Are they the same? Yeah, the slopes are equal, so these are parallel. Good. We're going to check the other set of lines now. And then BC. And then we're checking those two slopes. Are they the same? Yep, so these are also parallel. All right, so we've got the first condition. Opposite sides are parallel. Awesome. Now we need to check to see if consecutive sides are perpendicular. To check to see if those sides are perpendicular, what we're going to do is we're going to take the slope of one of the sides, which I'm going to call M1, and I'm going to multiply it to the slope of some other line that's right next to it, not across from it, but touching. I'm going to call that slope number 2. And what I want is for the answer to be -1. If that answer is -1, those two sides are perpendicular. If it's not -1, then they're not. Okay? So, pick one of these two sides, the pink or the orange. You pick. Which one do you want me to use? The orange. Okay. So we're going to multiply the orange slope times, and now we need to pick one of the ones touching the orange. So up here in my diagram, there's my orange line. So I need to pick either the green or the blue line. So one of these two. Which one do you want to pick? The green or the blue? Again, it doesn't matter, your choice. Pink? I can't do pink, I can only do green or blue. Green? Okay. So we're going to look at the green slope. Okay? And I don't know if this is going to be -1. Okay? If it is, they're perpendicular. Okay, the orange slope is 3. The green slope is -1/3. And I still don't know if that's -1 or not. I need to multiply these together. When multiplying with a fraction, if I turn everything else into a fraction, it makes my life so much easier. So I'm going to turn that whole number into a fraction, and now I can just multiply straight across. 3 times -1 is -3. 1 times 3 is 3. And -3 divided by 3 is? Which was what I was after to begin with. This means the 3 dots stands for, this means, therefore. Okay? Therefore, line segment CD, that's the orange side, is perpendicular to line segment BC, that's the green side. This, along with opposite sides being parallel, tells us that the quadrilateral ABCD is in fact a rectangle. And now that we know he's a rectangle, he gets allowed in and he can party and have a good time. Okay? Not too bad. A little bit of work to do, yes? Like there was a lot to do. And I get it. There was a lot to do. There's a lot of numbers to keep track of, but really you're only checking 2 things. Let me show you method 2. And that's where we'll end the day. We'll do method 2 and then we're done. I promise. I promise. I know you're tired. I know it. I know it. Let's do method 2 and then we'll call it done. Okay, method 2. Method 2 asks us to use distance. And we're going to use distance because we have to check the following things. We need opposite sides congruent. And we need diagonals congruent. This means we need to check 3 pairs of distance measurements. We have to have 6 distant measurements in total. We have to use the distance formula 6 different times. Okay? Here's what the distance formula says. Yeah, it's that one. I know. I can already see it on your faces. You hate this one. Here's the good news, is you don't need to run it all the way down to decimals. You don't even need to simplify the radical at the very end. All you need to do is do just enough work on the stuff inside to be able to tell what that number is going to be. Okay? 5, 7, 12, 50, 100, I don't know, whatever that number is. Okay? Because you just need to be able to compare them. So once you get it to the point where you can compare it to something else, stop. Don't do any more work. Okay? All right. Like with the other one, we need to compare the pairs of opposite sides. So here is side AB and here is side CD. They're opposite sides, so we have to compare them. And we want them to be equal. We then need to compare the other pair of opposite sides, which in my original diagram I colored in blue and green. So AD and BC. And again, we're looking for that result to be equal. So those are opposite sides. But we also want the diagonals. Okay? We need the diagonal from B to D and from A to C, and we need those two to be congruent to each other. Okay? I've got to do distance formula 6 different times. All right, let's do it. Let's start with AB. I'm going to zoom in a little tight here because the writing's going to get a little small. Okay, x coordinate for A minus x coordinate for B, y coordinate for A, minus y coordinate for B. Please, as we're doing this, double check to make sure that I've substituted correctly from the coordinates at the top of the page, that I've done the double negatives properly, that I've added or subtracted properly, that I've taken the square properly, okay? So don't just copy blindly. Okay. There's one distance. Gonna do CD now. These were the two I was comparing. Are they equal? Yes, those two sides are congruent. One down, two more sets to go. Again, I'm just substituting in from the coordinates at the very top of the page. Okay, and now I'm going to do the other side. And it looks like this one is the same value already. This was the next pair that I was comparing. And those are also congruent. Yeah? All right, two down, last one. At this point, I could say it's a parallelogram. To say it's a rectangle, I need this last pair to be equal to each other. If it's not equal to each other, this is not a rectangle. If it is equal to each other, it is a rectangle. Okay? Here I go. X coordinate for B, X coordinate for D. X coordinate, Y coordinate for B, Y coordinate for D. I have a double negative. Okay. So now I'm looking at the last one. If the last one turns out to be square root 50, this thing's a rectangle. The suspense, is it killing you? No, not really. Doesn't look like it's gonna be, does it? Oh, wait. Oh, wait. There it is. Congruent, congruent, congruent. I have 3 yeses. That means that quadrilateral ABCD is in fact a rectangle and is allowed inside the shape rectangle part. Okay? Neither one is really difficult, right? It wasn't hard. There was just a lot of paperwork to do, yes? Yeah, there's just a lot to keep track of. All right, questions? Please note on the homework at the bottom of the page, ask you to determine if it's a rectangle and justify using the indicated formula. So make sure that you're using the method that goes with that formula, okay? All right. That's it. Thank you very much.